All right. Hello, hello, hello. Today I am going to be going through ion notation, which is really just kind of a continuation of basic atomic calculations. So, in the last video, we talked about how to take the number of. One moment. And I'm back. Okay, we talked about how to take the number of protons, neutrons, and electrons and turn those into a lot of things. Figure out the element, identify the element, determine the atomic number, the mass number, the ionic charge, which has to have a sign, positive or negative, unless it is zero. Ionic charge must have a charge. Okay, identify whether it's cation, anion, or neutral, and then writing isotope notations. Okay, so isotope notation is like hydrogen 3, okay, or H3, H-3. Okay, that's an isotope notation. So you spent, to practice that, you filled out this thing, depending on which set you had, set 1 or set 2, but yeah, this was our first practice. Ion notation is really just a way for us to give you the other 3 pieces of information and have you determine the same stuff again, just in the other direction. So instead of giving you these 3, the electrons, neutrons, and protons, and asking you to figure out these, instead, we're going to give you these 3 and ask you to figure out these, as well as obviously everything else that's on here too. So ion notation is just a way of giving a lot of information. So I'm going to grab my whiteboard, write out the couple, and we'll go through those. And then I'll pull out the worksheet so you can take a look at it. This shouldn't take too long. All right, so this is the ion notation that we're going to be going through. So this is 59 over 20, there's a line on my screen, over 27 CO with an exponent plus 4. Okay, whenever you see something written like this, this is an ion notation. Okay, and there are a couple variations on ion notation, just FYI. This is the one that we're going to be using, though. Now, ion notation is formatted like this. Okay, so the number on top is the mass number. The number on bottom is the atomic number. Obviously, the letters are the element symbol. And then the exponent is the ionic charge. So we're giving you its elemental identity, its, twice actually, its isotopic identity, and its ionic identity, instead of giving you the particles directly and asking you to figure out these identities. We're just giving you the identities, and this time we want you to figure out the particles. So for this, we know that the atomic number has to be 27. Because right here, in the spot for atomic number, it's 27. The mass number, which is the number above, is 59. The ionic charge is the exponent, so that's going to be positive 4, not just 4, positive 4. And then from this information, we can figure out the element, the number of protons, the number of neutrons, and the number of electrons. The element, well, CO is the element symbol. I don't have room. Well, actually, I might be able to fit cobalt. Let's see. There we go. Okay, so cobalt is the element's name. If you don't know off the top of your head that cobalt is, or that CO is cobalt, you can look that up one of 2 ways. You can either look up CO on here, or, and this is the one that I would recommend, the atomic number is 27. So we can look at these blue numbers here. Those are the atomic numbers. If we scroll over until we find 27, I went past it. Also can't read. Is that it? That's it. Yeah. 27. Underneath it, it says CO, and then under that, it says cobalt. Okay, so we can get that from there. Now, for determining the number of protons is the atomic number still. Nothing new there. That's nothing new. Atomic number equal proton. So 27. 27. The number of neutrons, well, the mass number is the sum of protons and neutrons. So if we know the number of protons, we can take the mass number minus the number of protons to get the number of neutrons. So 59 minus 27 is 32. So there are 32 neutrons. And to get the number of electrons, we can do the same thing with the ionic charge. Okay, the ionic charge is the difference or subtraction of protons and electrons. So 27 minus whatever this is equals the number of protons. So we can plug that into our equation. We can solve that. The number of protons minus the ionic charge will give us then the number of electrons. Or, because negatives kind of suck, you can also say, well, my ionic charge is plus 4. Based on the fact that it is positive, what do I have to have more of? Well, if it's positive, you must have more protons. How many more? Well, 4. So there are 4 more protons than there are electrons. So what is 4 less than 27? Well, 23. And that's pretty much all there is to it. We can do the same thing with this next example here. We're given 23 over 11, Na plus 1. I want you to pause this and attempt this one, and then I'm going to go through this, and then you're going to pause it again and do the red one down here at the bottom. So, okay, I'm assuming at this point you've paused it and you're done and you're ready to go through it. So, element name, Na, is sodium. So we're going to write sodium. Atomic number is 11. The mass number is 23. The ionic charge has to be positive 1. Protons is the same as the atomic number, so that's 11. Neutrons is 23 minus 11, so that's going to be 12. And then this has a plus 1 charge, so there's 1 more proton. So there's 1 less electron, so this has to be 10. Okay, so pause this again. Work the red one here. Make sure that you've got this. All right, cool. So, element name, that's P. P is phosphorus, so phos. Forgot the P. Phosphorus. Atomic number is 15. The mass number is 31. Ionic charge is -3 this time. Protons is the same as the atomic number, so 15. 31 minus 15 gives us 16 neutrons. And the number of electrons, well, it's -3. So there are 3 more electrons than there are protons. So this has to be 18. And that is pretty much it for ion notation. So, to help you practice for ion notation, we do, of course, have one more worksheet for you to go through. This worksheet also has 20, but this time there are duplicate elements. Don't freak out when you get uranium twice or nitrogen twice or whatever else is on here twice. Okay, so this time we're just giving you, instead of giving you the bags, we're going to give you just the worksheet. So this has the ion notations in the first column, and then you need to figure out these 4 here, just based on what's in here, and then you can calculate the number of protons, neutrons, and electrons. There are 10 on each side of this, so work through that. Now, I'm going to give you a tip. If you want to actually learn what you're doing, okay, if you don't care, then you can ignore this. Stop this now because this is going to matter to you. But if you want to actually learn what you're doing, you need to do this 1 row at a time. Do A to completion, including the electrons and neutrons. Do the whole row, then start B, then do C, then do D. Finish a row before you go on to the next one. If you just shoot down this column, you will get it done faster. Yes, you will. but you won't learn anything. You are not going to retain anything that you do if you just shoot down the columns. If you want to retain it, you have to actually make your mind switch tasks. Okay? How do I get that one? 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 How do I get each one? Make your brain switch tasks. The fact that you have to keep doing it and switching back, that's what's going to help you recall by having to come up with that information several times. If you just go, okay, this one is just always the difference between whatever two columns, then just shoot down it, you figured it out one time. So you only did it once. You didn't do it 20 times. You did it one time. If you do it once on the front and then again on the back, you did it twice. The reason there's 20 here is so that you can learn how to get it. Work it one row at a time. The key for this is posted in Canvas. So when you finish, I had a couple people like to do the front, check it, and then do the back and check it. That's fine. Key is posted so you can check your answers, make sure you're doing it right. And then after that, we have one more for you. Yours will probably be a little bigger than this because this is just a little small. In this one, we are giving you randomly dispersed pieces of information, and you have to fill in the missing information. So it's the same basic idea. It's just that this time you don't always have the same stuff. So you have to kind of puzzle it out. How do I get what? I'm going to give you two tips on this one. The first one is the same as what I said in the last worksheet. One row at a time, not a column, a row. Work one row, finish it, and then do the next one. The second tip is start with protons. You don't have to start at one end of the row and go all the way to the other end. You may have to hop back and forth in the row to solve it. The first thing you have got to know is the number of protons, because the number of protons is in every single one of our equations. You have to know the number of protons. So that should be your first priority when you're working on these. Okay, and in case you haven't figured this out yet, the equations are on the back of your periodic table. Okay. Atomic number is equal to the number of protons. There's the layout for ion notation. Equation for mass number, equation for neutrons, equation for ionic charge, and the equation for electrons. They're all right here under atomic calcs. Now, if you have one of the older periodic tables, it may say like Unit 3 or Unit 1 instead. It's the box that's in this corner. It stands out. It's the only thing on the back of this that probably will make any sense to you. But yeah, so that's there. That should help. That's all I've got. So I'm going to say goodbye, and I'll see you in the next video.